Today we are going to be talking about the basics associated with physiological psychology. And in terms of our discussion for today, I do want to cover a little bit about the brief history related to physiological psychology, and then going on to just some basic ideas related to what it is that we do within physiological psychology and what it is that we tend to explore. So just to cover a very brief history very quickly here about physiological psychology, a lot of the work that we tend to do now within the field of psychology really revolves around a big question of where is the mind? When we think about where is the mind, big questions that always come up related to this topic are issues related to the location of the mind. So is it potentially in your head? Is it somewhere in your heart? And we have statements such as follow your heart, listen to your heart's desires, things of that nature that always gave us this inclination or this idea that potentially the mind was truly somewhere else other than the head. Now, we all would point to the head at the current state of time, but we would point to our head at this point in time within our lives because now we have a better understanding of the brain and how the brain truly does work. But remember that prior to our current abilities in terms of technology and our abilities to be able to monitor and explore the actual functions of the brain, we really didn't yet understand what the brain was really used for. And that's why there was a lot of misconceptions associated with the brain and also misnomers associated with the brain. So again, that's why the heart seemed like a very integral part to the functioning and understanding of the mind, because we would say things like follow your heart or listen to your heart's desires. So if we look back to trying to understand what the brain was really all about, Aristotle was kind of one of the first individuals to really tell us a little bit about the brain itself and talk to us a little bit about potential issues related to trying to understand this idea of the mind. And Aristotle talked to us about the mental functions, but them really being located within the heart. So again, not really being able to look at this issue related to the brain, but rather the heart, and potentially the heart being the seat of the soul or the location where we would actually have information that's being processed because we pump blood through that system. And in reality, the brain was thought for many years to being a cooling unit that was used to lower the temperature of a hot-blooded person, and the hot blood coming from the heart. So again, a lot of that drive that was coming from the passion or the heart was now being cooled down by this brain that we would have, but in reality, not really understanding what the brain was used for. Descartes later comes along and really tells us issues related to the brain and starts now trying to think of what the brain could potentially be used for. And part of it was that the brain was actually filled with animal spirits. So that's why we would actually see certain types of primitive behaviors or behaviors that would be more instinctual potentially coming out or manifesting themselves because our brain was filled with these animal spirits. And one of the things that Descartes really looked at was this issue of the pineal gland. And the pineal gland being kind of the junction where potentially the mind and the body might potentially be located. So he really thought that here the pineal gland was actually the seat of the soul. And why did he think that? Because if you actually look at the brain, and we're going to talk much more about the brain in the next coming weeks during this course of the semester, part of the brain is actually, or the brain itself is symmetrical in its nature. In other words, it's a mirror image of the left side and the right side. The only unique factor that we have within the brain is really this aspect of the pineal gland. So since it was very unique to itself, they assumed that here it would potentially be this seat of the soul that we would look at. Now, as we progress through the history of trying to understand the brain and looking at particular brain functions, a big issue that comes up is the issue of trepanation. And what is trepanation? Trepanation was actually a technique that was used to create this hole that we actually see in the person's skull using rudimentary techniques throughout different civilizations, not just in one particular civilization or one particular time in history, but throughout many different civilizations and time periods, that they would use this type of technique to be able to allow evil spirits to potentially escape from the individual. So rather than looking at potential psychological illnesses as being medical illnesses or being much more something greater than what they were considered to be, they were actually thought of as being possessions, or that we would have evil spirits that were dominating our thoughts or our brain, and thus we would create these holes within the head to being allow those evil spirits to get out. Now, there are other uses of trepanations. None of these are really truly scientific in their nature, except our last point here that I have of releasing pressure in the skull that is actually used in certain situations or in certain medical procedures, that is a scientific procedure that is used for that specific purpose. But there are other instances of using trepanation to, again, allow evil spirits to be able to come out of an individual's brain or that we would increase blood flow to the brain, and thus that would create greater intelligence, because more blood flow to the brain would thus mean greater intelligence for the person. So again, here we don't really see that trepanation is something that is very useful for us in terms of allowing evil spirits to escape or having greater intelligence, but yet that doesn't stop the general public for sometimes believing in it. So here I provided a website for you to go visit if you have a chance to, or a couple of minutes. And one of the things that they talk about in this website is that they have these so-called articles where they have empirical research demonstrating that the use of trepanation is much more reliable, and it's actually very effective in increasing an individual's blood flow to the brain, thus creating greater intelligence. But yet in reality, it is not. And like I do mention, the only technique that we actually do use it for currently in medical fields is really for the releasing pressure that sometimes does build up in the skull because of illnesses that may occur that do affect the brain, that do affect swelling in the brain. So if we're looking now at trying to understand and trying to figure out the brain's functioning, we've been trying to figure out the brain's functioning for many, many years. Franz Joseph Gall was the developer of an interesting technique called phrenology. When we come to class next week, I will talk and demonstrate phrenology a little bit more closely for you. But the idea of phrenology was really that there would be this localization of functioning in the brain. So in other words, our brain had specific mental faculties, and in these specific mental faculties, they were represented to us by feeling these bumps on the head. And the bumps represented psychological attributes. So we would have such psychological attributes as memory. We would have such things as desires for success. We would have motivation. We would have certain personality characteristics that could be distinguished by feeling these bumps on an individual's head. And part of what phrenology was used for was to try to explain how this localization of functioning actually worked. In our modern day phrenology, we would see something that would look like this in a comedic fashion, so none of this actually being empirical in its nature, but still being something that's similar to this, that we would look at differences between female and male brains and making jokes related to particular aspects related to this. So seeing how much of we actually have a commitment neuron associated for men. We have an area of the brain that's dedicated to sports versus issues related to mystery moods and behaviors for women, and so on and so forth. That is much more comedic in its nature. Nothing was really empirical related to this, but yet that was the same kind of general idea, that we're trying to understand parts of the brain and what the brain is truly used for in those particular cases. Now, one of the more famous cases that we actually have related to the idea of trying to understand the brain is the case of Phineas Gage. Now, with Phineas Gage, it's one of the most important and popular cases that we actually have within the field of psychology and the importance of the brain. But the idea behind the case of Phineas Gage was that this was an individual who suffered an accident while working to try and explode rocks that were in the way when they were trying to lay the railroad tracks back in the 1800s. So Phineas Gage was an individual that was the actual foreman of that project. And what they would do is they would go and they would find these rocks that were in the way of them laying down the railroad track, and they would make holes within the rock itself, and they would push down dynamite using what they would call a tapping iron. Now, that tapping iron was used to tap down those charges, and the rods that they would use were actually very, very large. Now, while they were pushing down some of these explosive devices down in these holes, there was a freak accident, and the explosive exploded at that time, sending that tapping iron straight up right in front of Phineas Gage, and it went right through his head, and it landed 80 feet away. Now you can see in this schematic that's to the top left of the screen, you'll actually see how it is that the trajectory of that tapping rod going straight through Phineas's head in this particular case, going behind his eye and missing his eye completely, and going out the top of his head and going out through what we now would call the frontal lobe. So what ended up happening? So in terms of what ended up happening with Phineas Gage and demonstrating to us the importance of the case of Phineas Gage was that we actually started seeing differences in terms of mental performance because of the damage that he suffered in his frontal lobe. It was actually said that before the accident itself, Phineas was a very calm, docile person. He was very generous with individuals, always very nice in terms of the way that he would communicate with others, and so on and so forth, and never used any curse words or anything like that. But after the accident, Phineas suffered this drastic change in the way that he actually demonstrated himself to individuals and he behaved around other people. They said that he would use curse words. He was very aggressive with individuals, would want to fight with people for no reason, made very bad decisions, and so on and so forth. And thus leading us to conclude that potentially the frontal lobe is important for aspects related to personality. So here, giving us this general idea that the brain was again important for specific issues and specific parts of the brain being very important for those types of behaviors or those specific types of characteristics or traits that we would now look at. So if we look more closely at the anatomy of the brain itself, because it is important for us to explore this anatomy, part of what we need to be able to explore is what we would call the gyri with our brain. Now, the gyri in our brain is what we would call these wrinkles or the gray matter. Now, within these wrinkles of this gray matter, we actually have or we contain the neurons at this point. Now, whenever it is that we see a brain and we see these wrinkles or these folds, the more folds that we actually observe in the brain, that means more sophistication of the brain itself versus what we call the sulci. The sulci is what we would call these spaces. Now, if we see a brain that has more spaces than wrinkles, that would mean that there's less sophistication of the brain. So what we want is we want a species that has lots of wrinkles, especially something that would look like a human brain. In the human brain, you see that there's lots of wrinkles, lots of folds, indicating to us that there is sophistication in terms of the brain of this species, and in this particular case, the brain of a human versus that of a mouse, for instance. So if you actually look at the brain of a mouse as we see here on the screen, you'll notice that they don't have very many folds or many very of those wrinkles that we just talked about, but rather they have a lot more just space that is visible here, leading us to conclude that they have less sophistication in terms of their brain functioning, in terms of being able to do higher order functioning that we would see in terms of what humans could do versus that of a cat. So here, if you notice with the cat, they have lots more folds than what we would see in a mouse, but less than what a human would have. Now, the one exception that we do see that they have lots of folds is right here in the back, right here where we would say that this would be our occipital lobe, the area related to vision. And if you do know one thing about cats, cats have great vision skills. So here for them being able to use visual processing is going to be vastly important for their survival. Thus, they would have to have very sophisticated systems to being able to observe. So if you actually think of cartoons like Tom and Jerry, where we would have Tom, the cat, always losing out to Jerry, the mouse, that's actually opposite. We would actually expect that Tom, he's much more sophisticated and smart, would actually be able to outsmart Jerry, our mouse, because he would not be that smart in this particular case, right? Based on what we would observe in terms of their brain development. Now, some additional issues here that I wanted to cover related to basic issues related to anatomy is the issue related to the cerebral cortex. Now, the cerebral cortex is that layer of tissue that's actually covering the two hemispheres of the brain. So what we actually observe here is that tissue above the covering the entire hemispheres of our brain that we observe here in this image to the top right-hand corner of our screen. Now, we also do have two hemispheres, like I mentioned in our previous point here, and our two hemispheres, we have them creatively named our right and our left hemisphere. Now, for our right hemisphere, this is the part of the brain that we would say is much more specific for spatial abilities, facial recognition, visual imagery, and music. Now, this does not necessarily mean that only the right side of the brain is able to control those functionings, but yet we do find that there is more functionality related to these specific characteristics and functions in contrast to the left hemisphere. Now, you'll also note here that the right hemisphere controls the muscles on the left side of the body, meaning that what we have here is what we would use the term contralateral. Thus, the left side of the brain, or our left hemisphere, controls the muscles that are on the right side of the body. Such issues related to language, math, and logic are much more dominant within the left side of our brain. Now, the last point here that I'll make related to the basic anatomy of the brain is what we call the corpus callosum. And what is the corpus callosum? The corpus callosum is this giant band of fibers that we have between the two hemispheres that allows for connections and allows for communication between these two hemispheres. Now, in some very extreme cases, the cutting of the corpus callosum is actually used in the treatment of very severe epilepsy. And as we go through the semester, I'm going to present to you some particular cases of individuals who had their corpus callosum severed for the purposes of the treatment of severe epilepsy. But yet, one of the things that we do find related to them is that we do have other issues that do arise and other problems that are sometimes encountered. Now, like I mentioned, we do have this issue related to how it is that we actually have projections in terms of our brain and what parts of our body do what, or what hemispheres do what. And one of the things I mentioned here was this issue of what we would call contralateral projection or contralateral control. And the aspect of contralateral projection is the idea that we have projections that are on the opposite side of the brain. So in other words, the left visual field is primarily being processed by our right hemisphere in this particular case, but yet we still do have some projections being processed on the left side of the body as well, such as with our what we call ipsilateral connections in this particular case. So here it's important for us to note not only do we have contralateral connections, but also ipsilateral connections, as we show here in this particular image. Now, the last thing I want to talk to you about before we conclude our lecture for today is the issue of the lobes of the brain. Now, with the lobes of the brain, we do have 4 specific lobes of the brain. Now, what are our 4 lobes of the brain? Let's first begin with what we call the frontal lobe and the parietal lobe. Now, the frontal lobe, here, the front part of your brain, right? That's going to be the lobe here that we have to the front part of your brain, handles executive functions. This is what we would call the decider. This is the person, or this is the part of the brain that is really involved with the planning of movements, memory, inhibiting also inappropriate behaviors. So part of what we want to do with the frontal lobe is making sure that we behave in appropriate fashions based on the social context, and the processing of that information, making sure that the decider portion of the frontal lobe is really inhibiting those inappropriate behaviors. And one of the things that we find is that with individuals who have something like what we would call frontal lobe syndrome, where we would find that their frontal lobe isn't working very well, they tend to act before they think. So in other words, they don't think about the consequences related to their actions or how that may hurt themselves or others, but rather they just engage in the behavior itself. And many times that behavior may be inappropriate behavior or maladaptive behavior, something such as gambling or having an addiction to a drug or whatever the case may be. Now here, do be very conscious of this. Don't go and classify yourself as having frontal lobe syndrome and say, oh, I must have that because I like playing the lotto, or because sometimes I do dumb things. We all do dumb things, and we all sometimes may go and buy a scratch-off ticket, and sometimes we may do things that were inappropriate and we didn't really think of it at that particular moment in time, but that doesn't mean you have frontal lobe syndrome. But again, these are for extreme cases of individuals that may actually suffer damage to the frontal lobe. Now, our second lobe here that I do want to talk about is what we call our parietal lobe. Now, our parietal lobe, which is the top portion of our brain here that you'll notice here on the left and also on the right side of our brains, because again, our brain is symmetrical. So we have a left parietal lobe and a right parietal lobe. This is much more in tune with trying to assess body sensations, such as issues related to pain and also temperature. So here, if we do notice that there are any pain or we're sensing any pain at any particular point in time, that is our parietal lobe processing that information for us. And we're going to talk about some particular instances where we have what we call our somatosensory cortex in our parietal lobe that is really functioning there for the assessment of body sensations and temperature changes as well. Now, the last 2 lobes of the brain that we'll talk about here is what we call our temporal lobe and our occipital lobe. Now, for our temporal lobe and our occipital lobe, our temporal lobe is on the right side and on the left side of the brain, right above our ear, and our temporal lobe is much more in tune with looking at issues related to emotions and also issues related to language. Now, primarily within our temporal lobe, we have 2 very important areas within the temporal lobe that are called Broca's area and what we also call Wernicke's area. Now, for Broca's area, this is the part of the brain within our temporal lobe that is very important for the production of language. Wernicke's area is much more for the purposes of comprehending language. Now, we do observe that if we do have damage to the temporal lobe, to Broca's area or to Wernicke's area, we end up seeing issues related to production with Broca's area or comprehension issues with Wernicke's area. And I'm going to talk much more about those a little bit later on in the semester when we talk about language. Now, last, we can also suffer from what's called prosopagnosia if we have temporal lobe damage, and this is where we have an inability to recognize individuals' faces. Now, this is a very, very detrimental disease or effect to damage that may be caused by, that may have happened to an individual. Yet, just because you may not recognize a person's face does not necessarily mean that you have prosopagnosia. So again, just to be cautious with saying that you have prosopagnosia, when in reality, we all tend to forget people's faces, or we may not recognize a person's face in some particular instances. Now, the last part of the brain here that we're going to talk about is the issue related to the occipital lobe. Now, with our occipital lobe, this is primarily important for vision. And we do a lot of visual processing in the occipital lobe. Now, there's a good reason why it's in the back of our brain. And the reason that it's back of our brain is because we are much less likely to get hit in the back of our head, but rather we tend to get hit in the front of our head. So if you think about that from an evolutionary standpoint in terms of evolutionary adaptation, it's very well adapted to put that in the back where we have the most protection, because we do depend so heavily on vision within our world. All right, that wraps up our discussion associated with our introduction to physiological psychology. When we come to class next week, we're going to talk a lot more about other issues and specifically about how we have communication between our hemispheres.